In our work with scatter plots and LSR lines, when we create LSR lines, we sometimes see points that are far from the trend line that we create, right? Far from the LSR line. And so when we think about those, we generally use the language of a striking deviation just to acknowledge like, hey, something weird is going on with those. And we need to do a little bit more investigating to classify those and see what they are and how they affect our results. And when we go into that analysis, we can identify those points that are far from the trend line as either influential observations or outliers. There is a difference between these two. So let's begin with defining what an outlier is. Simply put, an outlier is a point with a large residual. Now, when I use that language, that just means a vertical deviation from the LSR line. Okay, that's what a residual is. It's the distance that it is vertically from the trend line. Okay, so we can just visually inspect it and say, okay, yep, this one has a large vertical deviation. Large is a little relative, but at least we can say, we can identify it as an outlier just by visual inspection. Influential observation, this one is a little trickier to define. So this one is a point. So a point that has a large impact on the LSR line. Okay. And so it's the language there, it's like, oh, okay, like it has a large impact, but what does that mean? Really, what it means is what we have to do to determine if it's influential or not is take the point out and see if the LSR line changes. Okay, so here we have a few examples and we need to identify, which ones, or the square point as it were. So, here, here, and over here, if those are influential observations or outliers, and technically they could be both, right? Because if it has a large residual, chances are that it could also have a large impact on the LSR line, okay? So in this first one, if we look at it and, okay, well, here would be its residual, okay? And so is it vertically deviated from the LSR line of ways? Yeah, so I would say this one is definitely an outlier. Well, or we believe that it is an outlier. Okay, there's actual mathematics that we learned how to classify outliers, right? Now, in terms of it being an influential observation, so here you can see in this box it has two LSR lines made. So the solid line is the model using everything, that point included, and then the dash line is the point, or the LSR line if that point were omitted. And so as I look at them, does it appear like if we remove that point that the LSR line changes significantly? No. So I'm going to say that this one is an outlier only. Okay. Um, Now, under model B, right? So we're looking at model B, there's a square point. Okay, so so if I look at the vertical deviation here, that would be the residual that I've just drawn in blue. Is that vertically deviated in a big way from the trend line, from the LSR line? Yep, so I would say this is an outlier for sure. And then is it influential? So does the regression line change if I remove that point? So again, solid line is with the point in it, and then the dash line is with that point removed. And this one, it does look like the trend line changes a little bit, right? The slope becomes more positive. So I'm going to say this is also influential. It is possible to have both of these. It is also possible to have influential only and no outlier. Okay. Um, Chances are, though, if it's influential, it's also an outlier. Chances are. But here we go. So then now here we look at this point, and does it have a large residual? Is it vertically deviated? No, not really. The residual is actually pretty small there. So I'm going to say it's no outlier. And then the LSR line doesn't look like it changes a whole lot. So I'm just going to say not outlier. nor influential. I should actually say neither. Okay, English is the thing. Um, so there we go. All right. So neither outlier nor influential. Okay. So just some things to be thinking about as you're looking at scatter plots and LSR lines. Typically, if you have an outlier or influential point, you really want to remove it. But you also, when you do that, you need to acknowledge it. Some other things to be aware of when we're looking at regression in general, right? We had this concept of resistant measures, right? So if we add in large values, right, it doesn't really affect the calculation we do. And so here, because we can see through the past examples, if we have outliers or influential points present, it does change the LSR line. So that means it's not the correlation value R is not resistant. And also generally R at this level, we're only using it to describe linear relationships. There are curvilinear relationships too. Those have different calculations and whatnot. So we're not going to get into those in this course. And another thing to be aware of are these other terms. So just as we have like outliers and influential points, that's a key bit of vocab. Another bit of vocab that we need to be aware of is lurking variable and a confounding variable. Okay, now these are very tricky concepts. So lurking variables, it says, okay, so it's not the explanatory nor the response variable, but it has some relationship with the explanatory and response variable. Key thing, it is not in the study. Okay, but it could influence the relationship between the variables. Okay. We'll go through an example here in a minute, but so it has to be a variable that's outside of the framework for the study that could influence the study. Confounding, okay, it is in the study, okay, so that's the comparison, and it could have some impact on the variables, okay? So that's the key difference. Is it in the study or is it not? And so because of that key distinction, we just also have to say that these are not the same, right? So you can't have confounding versus lurking variables generally. Like you can't have the same variable being both. Okay. Um, and generally also the confounding, it messes with one of the explanatory and response variables, not both. That's just a general practice. So then here we're looking at this example here. So we're looking at, so in this study they're looking at weight. So that's the blue line, and then sale of ice cream. And so we're wondering like, okay, what could be lurking variables here and what could be confounding variables? So lurking variables. So what could impact sale of ice cream and weight, right? And so weight, as you look at the months, right, you start out heavy at a higher weight, I should say, in December, like the winter months, and then summer months it gets lower, and then it creeps up again in fall. And so if we think about that, right, so like and then also sale of ice cream, like sale of ice cream is low in the winter months, higher in the summer months. Well, so a lurking variable could be, climate or seasons, right? Something that could also explain like why more ice cream is consumed in the summer and why people are not as heavy in the summer, right? Now, a confounding variable, this could be a little tricky. So it has to be a variable that's being studied, right, that could influence the results. So what my response here would be is something that might be, say, price of ice cream. Okay, so maybe, for instance, um, in the summer months, right, they might decrease the price of ice cream to increase the sale of ice cream, right? Maybe. I don't know. That one, the confounding here is a bit of a stretch. And so here that would confound the sale of ice cream variable only. It wouldn't necessarily confound the weight. Okay. Um, maybe something that could confound weight is the type of food that is available, like seasonal produce, right? So in the summer months, you have more access to fresh vegetables, at least in the upper Midwest, compared to the winter months where you have less access to fresh produce, generally speaking, regionally, right? So we always import it, but that's a side thing. But that we would need to know if that was in the study or not. If it was in the study, then it would be confounding. If it was not in the study, then it would be a lurking variable. So we have to do a lot of thinking about the context to really identify these lurking confounding variables. Okay, so this video we looked first at trying to understand the different striking deviations that could exist within a LSR chart, and classifying those as either outliers or influential points or both. And then really the last thing that we talked about is this idea of confounding versus lurking variables. And so that's going to take some time and practice to work with. So we will get some practice as we work through other examples.